Hello, in this video lecture, we will discuss about Hall effect, dielectric behavior, piezoelectric behavior, ferroelectric behavior. Hall effect. What is Hall effect? The production of a potential difference across an electrical conductor when a magnetic field is applied in a direction perpendicular to that of the flow of current. So background, when a charged particle such as an electron is placed in magnetic field, it experiences a Lorentz force proportional to the strength of field and the velocity at which it is traveling through it. So this is a conductor, and when we apply a current with the left hand rule, so this is a flow of current and the perpendicular is the magnetic field. So electric field resulting at the Hall voltage at these two surfaces, okay, across these two surfaces, and it is perpendicular to flow of current and also perpendicular to the magnetic field. The Lorentz force experienced by electrons is F is equal to IB by N into A. So B is a magnetic flux. So this accumulation will create an electric field across the material due to uneven distribution of charge as shown in figure. This in turn leads to a potential difference across the material called Hall voltage VH. So the voltage across these two surfaces is known as Hall voltage or V suffix H. The force on electrons due to electric field balances the Lorentz force. Strength of electric field is Q into capital E, where capital E is equal to IB by Qn into A. The magnitude of Hall voltage VH is the strength of electric field multiplied by width of the material. So VH is equal to W into E. So WIB divided by Q into N into A. So ultimately V suffix H is equal to IB divided by Q into N into T, where T is the thickness of material. Dielectric behavior. So what is dielectric? So it is also known as insulating materials. Okay. The difference in the name between dielectric and insulator lies in the application to which these materials are put. When these materials are used to prevent the flow of electricity through them on the application of potential difference, then they are called insulators or passive dielectrics. On the other hand, if they are used for charge storage, then they are called dielectrics or active dielectrics. Materials such as glass, rubber, wood, and porcelain provide electrical insulation between two conductors at certain potential difference and also serve for storing electrical charge under certain other circumstances. In an ideal dielectric material, all the electrons are tightly bound to the nucleus of the atom. As a result, there are no free electrons available for conduction. This is the reason for them to be non-conducting. Generally, the dielectrics are non-metallic materials of high specific resistance and have negative temperature coefficient of resistance. The behavior of dielectric material can be changed by the application of an external electric field. So here in this figure, you can say without applying electric field, and this is the applying of electric field. We know that in an atom there is a positively charged nucleus at the center surrounded by the orbiting electrons or electron cloud which are negatively charged. An isolated atom does not have any dipole moment since the centroid of the negative charge distribution and the positive charge coincide. So there is no dipole in this case. But when the external electric field is applied here, it causes the electron cloud to move away. Thus, the centroids of the positive and negative charge now no longer coincide, and as a result, an electric dipole is induced in the atom. Thus, the atoms are said to be polarized. Therefore, polarization is defined as the process of creating or inducing dipoles in an electric material by an external electric field. The polarization increases with the field up to the critical value. On the basis of polarization concept, dielectrics are the material that have either permanent dipoles or induced dipoles in presence of an applied electric field. They are classified into two categories, namely polar and non-polar dielectrics. Non-polar dielectrics. An electric material in which there is no permanent dipole existence in the absence of an external field is called non-polar dielectric. This is because in this type of dielectric, the centroids of positive and negative charge of the molecules consisting the dielectric material coincide. Examples are hydrogen, nitrogen, oxygen, carbon dioxide, and CH4, that is methane. These molecules are called non-polar molecules. And last, polar dielectrics. A dielectric material in which a permanent dipole exists even in the absence of an external field is called polar dielectric. This is because in this type of dielectric, the centers of the positive charges and negative charges of the molecules constituting the dielectric material do not coincide even in the absence of an external field. Examples are H2O, HCl, and CO. These molecules are called polar molecules. Piezoelectric behavior. What is piezoelectric? So piezoelectric refers to the property of certain solid materials where these materials can accumulate the electric charge upon the application of mechanical stress. In other words, it refers to the electricity resulting from pressure and latent heat. This property is named as piezoelectricity, and the materials showing this property include crystals, certain ceramics, and biological matter such as bonds, DNA, and various proteins. The piezoelectric effect can lead to the linear electromechanical interaction between the mechanical and electrical states in crystalline materials having no inversion symmetry. This effect is reversible as materials that can show piezoelectric effect can also exhibit the reverse of the effect. It is the generation of the mechanical strain that comes from an applied electrical field. So here you can say that when we apply the pressure on this material, piezoelectric material, we will get the electric pulses, or you can say electricity. Application of piezoelectric. Piezoelectric igniters are commonly used for butane lighters, gas grills, gas stoves, blow torches, and improvised potato cannons. Electricity generation. Some applications require the harvesting of energy from pressure changes, vibrations, or mechanical impulses. And now, ferroelectric behavior. What is ferroelectric? Ferroelectric refers to the property of certain materials having a spontaneous electric polarization that is reversible through the application of external electric fields. All ferroelectric materials are pyroelectric, but it has an additional property of reversible natural electrical polarization. The term ferroelectric comes from ferromagnetism, which was discovered before the discovery of ferroelectricity. This type of material is useful in making capacitors because of their non-linear nature. These capacitors contains a pair of electrodes that sandwich a layer of ferroelectric material. The spontaneous polarization of ferroelectric materials implies a hysteresis effect where we can use it in memory function. Ferroelectric capacitors are useful in making ferroelectric RAM, ferroelectric materials. For example, barium titanate and rock salt are composed of crystals in which the structural units are tiny electric dipoles, that is, in each unit the centers of positive charge and negative charge are slightly separated. So these are the examples of ferroelectric materials. Ferroelectricity is a characteristic of certain materials that have a spontaneous electric polarization that can be reversed by the application of external electric field. All ferroelectrics are pyroelectric with the additional property that their natural electric polarization is reversible. Thank you very much for watching this video.